Hi, I'm Peter Haddock and I'm here today on one of the exciting visits to the stand here at Komatsu. I've been talking to Richard Clement to my right here for some time now. Richard, we had a massive discussion about smart construction in the pandemic over Zoom, and now we're here today on stand at the Komatsu stand at Futureworx because it's all real. And since that time as well, you've created Intelligent Machine Control 2.0. Tell us all about this first, Richard, and then we're going to explore the rest of the whole journey for smart construction.
Okay, yeah. In IMC 2.0 is Komatsu's second generation of intelligent machine control, released both for excavators and for the dozers. We haven't got the real machines here, unfortunately, but we have got some 150th scale. Why we're talking about intelligent machine control is a lot of this Futureworx has been about the connected and autonomous plant journey and the levels, and it's very appropriate for us to talk about both the intelligent machine control and the features, and also our smart construction side of the business. IMC2, to pick up on your original question, we built on the experience of the first generation of intelligent machine control. We've added additional functionality both to the excavators and the dozers. For the European market in particular, on the excavators, it's about the auto tilt bucket. Now, as the tilt bucket comes down, it will actually meet up with the surface on an angle and will adjust as you stroke in. So very, very useful feature for European customers who are heavily reliant on tilting. For the dozers, some very clever, what I like to think of as artificial intelligence or machine learning. The machine will actually look at the current surface it's tracking across, it'll look at the design surface, and it will actually decide how many passes to take. So it's actually helping the operator to make that decision. Instead of just going in on one pass and then having to shed some of the load, it's actually helping them to work out the intermediate layers that they need to cut. So some very, very clever, high-value solutions on our second generation.
And I think what's really important is machine control is now being mandated. We're here, and you've just talked about the CAP group for national highways. It's mandated on there, but we need to keep improving the outcomes and supporting the operators. And that's what this technology is actually doing, supporting the operators on site. But the CAP journey is a big one. And so come over here, because this is where it all starts here. And I'm going to come to the side. We've got levels down here and levels up here. So we've got products, and then we've got the smart element for Komatsu here. So the processes. So Richard, come in, Richard, a little bit tighter for me, and just explain to me, what is this all about, this model and this process? It's not just about machines anymore, is it?
No, we see the job site of the future will be a safe, smart, clean environment, and that's sort of the 5x5 top of this matrix. But it isn't just about the machinery. We've seen IMC 2.0, that's helping the operators. That's taking us down the product development route, and autonomy will come. We've got the mining machines, etc. But to complement that, it's necessary to look at how you run the job site. What is the process management? So we like to look at it in this two-dimensional format. The y-axis, the vertical here, is all about how to manage your job site. 3D data, designs, current terrain, progress, data capturing, converting that into information, and helping the customer to run their job site in an optimal manner, no matter where they are on the technology track in terms of the product. So even if the customer's fully conventional at IMC, or then is moving up to level 4, level 5 autonomy, there's still a necessity to complement the product with smart construction, job site optimization.
And what's really exciting for me is we're talking earlier, Richard, and fundamentally their journeys that are going through at the moment are all the way down here and all the way up here, and you're now doing a lot of smart construction job sites and supporting businesses. We're talking about sites in Germany at the moment, which I hope to pop through as I'm going towards Bauma, where customers are taking that journey with you and you're supporting them through that. How does that work, and what are we looking at for these kind of projects?
Well, our principle is very simple. We start by looking at the customer's process, not just the construction process. It'd be very easy just to say, hey, buy that machine, put it on, you'll do really well. But what we do is look at the business process from when they get the tender, responding to that, their pre-construction phase, then the construction and the final completion. we plot out that whole process and we try and identify where digital technology of some kind could actually help them to optimize their process. That could be a very simple solution, getting rid of paper, speeding up communication, something like that, or it could be a long drawn out process. And the point is, we will work with that customer, implementing the technology, guiding them, training them, coaching them through that to solve those pain points with the ultimate aim of creating a fully digitally transformed business process, including the construction phase, that gives them the optimum performance. So it's not just about moving material with yellow metal, it's about the whole digital journey from getting a tender to completing the job.
And what's interesting about this, folks, I talk a lot about this, so we talk about digital twins now, so we talk about putting drones in the air to map a site, creating the digital twin of that site as to how we want to look at that. And then we talk about how we take the digital twin and do a digital rehearsal to say, how are we going to deliver this digital twin? We could do it this way, but that would mean that we have problems over here or over here. We could re-engineer some of the elements, so removing less material. We could do things differently, go back to the client and say, what if we remodeled the whole process at the start to enable us to have a better and more incorporated site?
I mean, there are simple things you can do, like a cut-fill balance. You know, lifting the surface by 50 mil over the whole job site means net zero material in out, so a balanced cut-fill. That's great. But a lot more complex job sites, we're looking at doing a simulation. So you called it a rehearsal, we call it simulation. So looking at what's the most efficient way of moving material from cut area A to fill area B or C or D, intermediate stockpiles, haulage routes, etc., etc. Give the customer options. Does he want the quickest delivery or does he want the lowest number of machines used on the site? What are the options? Again, depending on what their business process is, what the circumstances are, it's all about what the customer wants and what the customer needs, not what we think is right for them.
And that's also very important, because for me, this is where this whole process comes in here, which is showing the customer the actual site itself and how does that actually work. Richard, this is a whole map we see in front of us down here of the job site. What is that actually telling us in real time, Richard?
Okay, and this particular example here is our demonstration area up in Bertley at the factory.
Right, okay.
This has got on it, it's got the design that we want to create, so the final surface. It's got the original surface that we started with, and then it's got intermediate surface data generated both through drone flying, but also data from the intelligent machines coming in, so the as-built data fed in daily, and from that we can then say, how far along are we? What's the progress towards the final design from the starting point? What volume's left to go? How much have we moved since the last survey? All of those kind of performance data can be visualized and measured on our dashboard. And we're very, very conscious that to understand what's going on a job site, terrain is one aspect, and this is all about terrain. It's then about machines, it's about material in and out, and it's also about the people. So what we're introducing is a set of tools that, if appropriate, we can apply on a job site, understand the terrain, understand the machine interaction, understand material delivery, understand the hours that the operators have put in, all of that in very, very near real-time situation, so managing the site becomes a lot easier.
Now, it's real-time really that I see as a big advantage, because if you've got a project and you can see things are happening on site, and Richard, this is really important, if you can see that, you can make actions and you can do things. We also have the anomaly that is the weather that impacts us, and when we're collecting data in this way and we're seeing how a job site works, when we actually factor that in, we might make changes to the kind of machinery we operate in weather conditions and how we catch up, because there's no point in getting bogged down in the detail of a project if you're bogged down in the project itself. So over here is the next part of this smart construction journey. And I think, you know, for me, this is one of the other facets of how we've got to actually deliver for better for clients and for the environment. So what have we got here when we're looking at all of this?
When you employ machine control and machine guidance technology, it's very important to be able to communicate to the machine in two ways, i.e. send your files to the machine, and receive data from the machine.
Yep.
One of the important aspects is also to support the operators. So if the operator's got a problem, doesn't know quite how to do something, you need to be able to dial in remotely and say, this is what you need to do, etc., or here's the new file. What we recognised very early on was that much though we'd like customers to have 100% Komatsu machines, people don't.
No, exactly.
So what we've developed here is what we call Smart Construction Remote. This enables us to do file transfer and remote support to Komatsu IMC machines, but also to Topcon and Trimble equipped machines.
Right.
So it's a brand agnostic approach to supporting customers, recognising that this is likely to be the systems that they're using. We're hoping to add other ones to it, but we're still in development with that. But what it means is, from one system, you can have all your machines showing, no matter what brand they are.
And so you've got one dashboard that gives you all of the information. You've got that bringing in all of the information from Intelligent 2.0. You've got all of the stuff we've talked about from the whole setup of the site in particular. And that's why, Richard, we've called it Smart Construction with Komatsu, because it's actually doing all of those things, putting it in one place and being smart so the customer has all the data, all the information they need, the operators are supported, the whole piece is brought together, and so that we can save money, save time, do things better, and ultimately reduce our carbon emissions and our fuel burn and be better guardians of the planet as we go through our smart construction journey. Thanks so much, Richard.
Thank you
very much. It's been great to see you in the flesh. It's been some time I've been wanting to have this conversation with Richard. Fascinating how you're doing this and how it's developing for customers. Cheers.
Thank you very much, Peter. Pleasure.